Hi, I'm Senuk, a PhD candidate from PostTech, South Korea. I will be presenting CorrespondentDream, enhancing 3D fidelity of text to 3D using cross-view correspondences, which was accepted to CVPR 2024. This work is done during my internship at ByteDance. A quick sneak peek of what CorrespondentDream can do. It enhances the 3D fidelity of text to 3D generated outputs without any explicit priors. We'll have to talk about how text to 3D works. As of now, there are various approaches to this, but when Dream Fusion first made text to 3D generation possible, it is by using a pre-trained text-to-image diffusion model as a critique to optimize a NERF model based on the text prompt. The NERF is updated in an iterative manner from random initialization, similarly to the video shown here. This optimization was made possible by score distillation sampling, or SDS for short. The problem with this approach was that because it uses a single view diffusion model as the critique, the generated 3D representation lacks 3D consistency, resulting in the multi-phase Janus problem or the content drift problem. To tackle this issue, Dream introduced a multi-view diffusion model, which was then used as the critique instead of the single view diffusion model, dramatically improving the 3D consistency of the optimized 3D representation. However, despite the improvement in 3D consistency, the 3D fidelity still remains an issue. By the term 3D fidelity, we refer to the coherence of the generated geometry with human common sense. For example, we can say a generated 3D object has high 3D fidelity if its geometry and surfaces are smooth, detailed, and complete. However, using single or multi-view diffusion models as the critique provides 2D priors only. The disparity in dimensionality between the 2D priors and the final 3D representation makes it insufficient to ensure the 3D geometry fidelity of the generated output. In this work, we present CorrespondentDream, whose aim is to improve the 3D fidelity of text to 3D generated outputs by using cross-view correspondences. When utilizing a diffusion model as a critique, we first render a view from the current 3D representation, add noise to it, and then forward it through the frozen diffusion model. Within the frozen diffusion model is a UNet, where we can yield 2D features of the rendered views from the upsampling layers of the UNet. These features can be used to establish cross-view correspondences between the rendered views, which have shown to be surprisingly robust and accurate in recent studies. We refer to these correspondences as CorrDiff. In practice, we render extra views which are closer to each other in terms of azimuthal angle, so that the adjacent views will have high overlap with each other, consequently having higher number of correspondences. The existence of 3D infidelities imply inaccurately rendered depth in the 3D representation. Given ground truth camera poses of each rendering and the rendered depth, we can obtain pixel reprojection across viewpoints, which can also be regarded as correspondences. We refer to these correspondences as CorrNeRF. In CorrespondentDream, we aim to correct the incorrect rendered depths by using the cross-view correspondences as guidance. Specifically, in the iterative update of the 3D representation, we introduced the correspondence loss, which aims to minimize the discrepancy between the CorrDiff and CorrNeRF, where we use CorrDiff as the pseudo ground truth to correct in CorrNeRF. We optimize our NERF by applying the SDS loss and the correspondence loss in an alternating manner. This is because the 3D optimization requires the time step to be sampled across a large range to cover both geometry and detail, while the correspondences computed from the diffusion features show higher robustness and accuracy when the time step is 0. Overall, we're able to improve the 3D fidelity of text to 3D without any new parameters or off-the-shelf supervision, using annotation-free cross-view correspondences. We present some qualitative results in this video, where it can be seen that the 3D infidelities are significantly alleviated to provide us with high-fidelity 3D asset. For more info, please refer to our project page, where you can also find our paper and code. Thank you.